All right, guys, we are going to work on analyzing important features of a function's graph today. So we do have a lot of vocab in this section, so you can go ahead and start copying down some of that information. We've talked about domain a little bit. Domain, of course, is the x values of the function. So here you have kind of the technical definition, but kind of off to the side for all of these. I'm going to kind of try to explain this in layman's terms here. So the domain is all the possible x values. So again, it's how far left and right the graph goes. And of course, the y values are the values on your graph that are vertical from one another. So it's how far north and south or up and down the graph goes. And then we're going to work on some examples here in a second. I think that'll help with some context, putting a lot of these definitions in use in just a second. Then next we've got intercepts. This is definitely something you've talked about in other math classes, and we may have discussed a little bit in earlier videos. X-intercepts and y-intercepts. Of course, x-intercepts are the coordinates where a function touches the x-axis. So the coordinates are always going to be of this form. It's going to be some x value. The y value is always 0 at the x-intercept, and vice versa for the y-intercept. So when you touch the y-axis, x is always 0. Now this last one, this may be a new word for you, a zero. A zero is the value that zeroes out a function. And basically, as long as we're talking about real zeros, it's the exact same thing as an x-intercept. So they're kind of interchangeable right now as we're talking about just the real number system. A lot of times we talk about x-intercepts when we're graphing, and we talk about zeros when we're solving some of these problems algebraically. But again, a lot of times they're irreplaceable. You'll see sometimes questions will ask for zeros and sometimes will ask for x-intercepts, and they're really the same thing unless we're talking about imaginary zeros, which is further down the road. And then finally, in behavior and increasing, decreasing constant. So in behavior, first off, is the direction that the two ends of a graph are moving. So it's literally how the two ends of the graph are behaving, really. We use the word moving, but it's behaving, again, one of those interchangeable words. The notation for in behavior looks like this. So you're going to see so that's what the notation looks like, and basically it's saying this. I'll write what those symbols mean. As x approaches infinity, y approaches, and we don't really know without having an example in front of us, but that's going to be the format of how you write in behavior. And of course, there's two ends. There's the right end, which is demonstrated right here as x approaches infinity, and there is the left end. So you can guess the left end is when x is approaching negative infinity. When x is getting really small, we're moving to the left portion of that graph. And then finally, increasing, decreasing constant. Increasing, it's sections of the graph where the y value is going up. And I've capitalized the word up because basically you're just looking at the graph. When it's increasing, the graph is going to be going up. When the graph is said to be decreasing, it's going to be going down. Now the key for increasing, decreasing. The hard part of this is remembering that you use only the x values. To write your answer there. So again, highlight that, put stars around it, because to determine where it's increasing, decreasing visually is actually pretty easy for most people. but remembering to use the x values when you write your answers, the tricky part. So we're going to do example 1 together, and we're going to go through all these different characteristics, and then we're going to skip the next couple, and I'm going to have you do a couple similar problems on your own. So let's look at example 1. So this is obviously the parent function for y equals x squared, and we're going to start by listing the domain of this graph. Remember, domain is how far left and right the graph goes, or in other words, it's the x values. And this graph is, most people say, oh, it's going up, but it's also going up and it's going to the left. It's going up this end, but it's also going to the right. So it's going left and right forever, which means the domain is negative infinity to positive infinity. Of course, that's interval notation, which is fine to use, but since it's all real numbers, we can also just say x is all real numbers. And that fancy R just means just that, all real numbers. And if you're worried about forgetting that symbol, you can always write out the phrase all real numbers, but that's shorthand. The range is how far up and down the graph goes, or in other words, all the y values that are covered. This graph we've already established is definitely going up. Both ends are going up, in fact, forever, but it doesn't go down forever. The lowest y value occurs right here at y equals 0. So it's everything greater than or equal to 0. So interval notation for this one goes from 0 to infinity. Again, interval notation is what I prefer, but you can also, if you're comfortable with set builder notation, except this is range, so we're not going to use x, we're going to use y. Zeros. Remember, zeros and x-intercepts are one and the same. So we look at our graph. Where does this cross the x-axis? Where does it zero the function out? Well, the answer to that is right here at the origin. So typically the way we write our zeros are we write x equals, and we write that x coordinate. The way we write our x-intercept is typically an ordered pair. Although we will see some people write x-intercept as x equals 0 as well. The y-intercept is where it crosses the y-axis. What crosses the y-axis? The same place it crosses the x-axis at. All right, and then finally, increasing, decreasing constant. Remember, use your x values here. So increasing, start with this one. Find where the graph is going up. Kind of treat the graph like a roller coaster. So the graph initially starts going down, and it's really at this point right here is when it starts trending upward. We read a graph like a book from left to right. So as we're going from left to right, that green section is the section that is said to be increasing at. So we're going to use the x values. So the leftmost x value there is 0. And we always use parentheses for increasing, decreasing constant. And then the question is, does it ever stop increasing? Of course, the answer to that is no. It's going up forever. So if it's going up forever as we're moving to the right, the x value we're going to use is infinity. All right, so now decreasing. Decreasing, you may have guessed, is this section right here, because from left to right, it's going downhill. Read a graph like a book from left to right. So this one starts decreasing from this direction right here. And of course, it's coming from this direction forever. So it starts decreasing at negative infinity, and it doesn't stop decreasing until that anchor point right there at 0. Of course, constant is kind of where the graph flatlines, where it doesn't change. This graph is not constant anywhere, so I'm just going to put not available in A. And then finally, in behavior. Again, we have two ends to this graph. There's a right end and there's a left end. So let's first look at as x approaches positive infinity. Which end do you think we're looking at when x approaches positive infinity? If you guess the right end, you'd be correct, because it's the right end where x is getting bigger. As we continue to move to the right, x continues to get larger. So when it says in behavior, as x approaches infinity, what is y approaching? So as we look at that right arrow, is it going up or down? The right arrow is going up forever, so y is approaching positive infinity. The other end then has to be the left end. X approaches negative infinity, means x is getting smaller. So if we look at that left arrow, is it going up or down? It's also going up. So finally, what I want to finish with, in another video, we're going to tackle some trickier functions like example 2 and 3. I want you to pause the video and I want you to try number 4. And then I'm going to go over the answers to number 4 here at about the 12-minute mark. All right, so here's the answers to number 4 before you guys try number 5. And again, for increasing, decreasing, you always use the x values, and you only use parentheses. Take a look at those answers. Go ahead and try number 5. Again, you'll notice these 3 examples, since they're similar graphs, there's going to be a lot of answers that are similar. But press pause. I'm going to go over the answers to number 5 here in about 5 seconds. All right, so here's the answers to the last page. And again, I've got some or answers here. You don't have to have, like for domain or range, you just need one of these 2 answers. For domain, you do not need both. Same goes for range, whichever one you're more comfortable with. However, if it's multiple choice on an exam, you need to make sure you know how to use both.